Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, saya Kurnia Illahi dengan NIM 190341114 dari kelas Fisika C. Baiklah, saya akan membacakan narasi tentang the map of Physics. So, Physics is a hard subject that cover many different topics, going from galaxy in the depth of space right down to subatomic particles. And if you don't already know physics, it's difficult something to see how all these different subjects are related to each other. So this is my map of physics. I hope you enjoy it. Physics can be broken down into three main parts: classic physics, quantum physics, and relativity. Well, we will start with classic physics, and a good person to start with is Isaac Newton. His law of motion describes how everything made of matter move about, and his law of universal gravitation tied together the motion of planet in the sky with the feeling of object on earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used over of centuries to drive new physics. Calculus is really part of mathematics, but physics and mathematics are inseparable. Mathematics is language of physics. You can imagine it like the bedrock that the world of physics is built from. Newton also made strides in the field of optics, which is physics of the light and how it travels through different material. It explains reflection seen in prisms and lenses, which are used to focus light in telescope, microscope, and camera. Optics is closely related to the theory of wave, which is basically how energy can travel through disturbances of a medium, like ripples on the surface of a pond or sound through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still allows the same principle as all wave, namely reflection, refraction, and diffraction. The leads to electromagnetism. The description of magnetism, electricity, and more generally. It was a physicist called James Maxwell who discovered that there are two aspects of the same thing to derive of wonderfully elegant rules of electromagnetism, and theories that light was an electromagnetic wave. Electromagnetic also explain all of electricity. Jumping back a little bit, classic mechanics is related to Newton's laws and covers the properties and motion of solid objects, how they move when force hit them. They happen when they are joined together. Fluid mechanics is described of the flow of liquid and gas. Using fluid mechanics, you can work out how much lift is generated from an aeroplane wings or how aerodynamic occurs. Thermodynamics is a description of energy and how it passes from one form to other. It also includes entropy, which is a measure of order and disorder, and basically tells you how useful different kind of energy, and energy is fundamental property to physics. So that is all of classic physics, the picture of the universe we had around the year 1900. It told us we live in the universe where everything runs short of like clockwork. If you could measure everything accurately, enough the future of kind of predetermined. However, not everything was solved. There were just a few of holes in experiment that hint at something more. Besides, at the time thought the would solve and explain this problem soon enough, but poking at them they unravel the few domain of relativity and quantum physics and turn on understanding of the universe complicate complete on this head. Albert Einstein was the genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light is constant for all observers. With that mean, when you travel really fast, where stuff start happening like time slow down. It also states that energy and matter are different aspects of the same thing, thus the famous formula E is mc squared. General relativity said that space and time are part of the same fabric called space-time, and the force of gravity comes from object bending space-time, making other objects falling in toward them, while relativity describes the very big. Other physicists were busy at work on the very small in the world of quantum physics. Nuclear physics describes how the nucleus of atoms behave and explaining radiation. Nuclear fission of the splitting the atom used in our nuclear power plants, and the nuclear fusion, which takes place in the sun, will be had fully sun be harnessed here on the earth. Particle physics problem even did to find the fundamental subatomic particles that everything is made of are described on the starting model of the particle physics. Quantum theory captures all of quantum physics and combines it with the special theory of the relativity and the best description of the universe we have. Unfortunately, quantum field doesn't include gravity, and so physicists don't know how to join together quantum physics, and they generally theory of the relativity leading to giant chunk of ignorance. One day in the future, we have to close this chasm and come up with a theory of all of physics. We call it quantum gravity. And there are many attempts to this. Some explain our string theory or loop quantum gravity, and there is many more. But quantum gravity is the only things we observe but don't understand. There are also the major puzzle of the dark and the dark matter, which seem to make up 95% of the universe. So all of our physics only really describe 5% of what we don't know about, and everything else at the moment is a mystery. There are many other mysteries out there like the Big Bang, and no doubt there is beyond that we don't even know what that we don't know, which get to the lofty cloud with float over of physics philosophy. Although many physicists make fun of philosophy, it's the big philosophical question. that motivate a lot of physics, like what is the fundamental nature of reality? How come the universe even exists? Do you have free will if we are just made of physics? Or how do we do know what the why that we do physics and science actually get the fundamental truth of the universe? And just why is the physics like the why it's well, just are the big question, one the big we might or may never answer. But that is no reason to give up. Try after all, physicists are not quitters, and that was in the map of physics. So that the end, and thank you for watching this video. I hope you enjoy it, and Assalamualaikum warahmatullahi wabarakatuh. Bye.